Good afternoon, dear students. So, today we will start the 21st chapter, that is straight line graph. So, as you have seen in these chapter 17, 18, 19, 20, 21, these are related with the graph. They are interrelated, and in this chapter, straight line graph, the various topics which we have, which we will discuss and which we have studied, they are already a kind of repetition. So straight line, when we plot any straight line on a plane, so we need the horizontal axis and the vertical axis, and with respect to origin we plot the points, because on a line there are infinite many points. So we generally start with the horizontal axis, that is x axis, and the vertical axis, that is the y axis, and where both these intersect, that point is called origin. So we will start this chapter with the equation of line. The equation of line, then we will discuss what is the general equation of line, then the relation between two. We will discuss again, that is the gradient, and the last we have in this chapter the line which are parallel to each other and the lines which are perpendicular to one another. So the equations of these lines which are parallel or perpendicular to each other. So let's start. If we have the Cartesian plane, we are talking about two-dimensional. So O is the origin. So with respect to O, if we have a point like any point, and suppose we have a point 3, 4 here, and a line is passing through this point, and this point is A. It is having vertices, the x coordinate and the y coordinate, and we have one more point that is like 1 and 1 here, or we can take any point anywhere. So in order to draw a line, we need minimum 2 points. So if one point here is the x, that is x coordinate is 3, this distance is 3 here, and the y, that is 4 here. If any other point which we are taking, another point is 1 and 2, B point whose coordinate is 1 and 2. So when we join these 2 points, we have a line, a straight line. So from 2 points, any 2 distinct points, we have only one straight line. And how many other points on this line? Infinite many. So we have infinite many solutions of this straight line. Now we have discussed about the gradient. So gradient of the line can be found, that we have already discussed. Gradient is y2 minus y1 upon x2 minus x1. What does it mean? Gradient means the perpendicular distance, the difference of, this is the perpendicular distance here between these 2 points and the horizontal distance. This is the perpendicular distance and this is the horizontal distance. This is the perpendicular distance and this is the horizontal distance between the 2 points, and this is, as we know, is represented by small m, that gradient, right? Now slope can be positive, slope can be negative, slope can be 0, or slope can be infinite. So we have discussed if a line, this is a line and one more line here. So this line is having a positive slope, a positive gradient. The gradient and the slope is one and same thing. Gradient and slope, one and same thing. So here, when a line is having this kind of slope, that is always positive, and here this is the negative slope or the negative gradient. So let me make you more clarify by taking the slope of any horizontal line or the slope of any vertical line. As we have discussed that the slope, that the gradient is y2 minus y1 on x2 minus x1. So if we have a Cartesian plane, this is x-axis and y-axis. Now any line which is parallel to this x-axis, that is the line, the dotted line which is parallel to, if we take any 2 points anywhere, on that one point is A and one point is B with the coordinates, and if we find the gradient y2 minus y1 upon x2 minus x1, so here these points, the line which is parallel to x-axis, the value of y remains the same. So y2 minus y1 is always 0. So for this case, y2 minus y1, y2 minus y1, that is always 0. And 0 multiplied by anything is always 0. So we can say that the slope or the gradient of the horizontal line is 0, whereas the slope or gradient of the vertical line, any line which is perpendicular to x-axis and parallel to this y-axis, again its slope, the slope of the perpendicular line is infinite, because here the x coordinates, they are same. Any 2 points, that this point is P, Q, so x coordinate that is same. So x2 minus x1 or x1 minus x2, that is 0. So y2 minus y1 upon 0, that is anything divided by 0 is infinite. So slope of the vertical line is infinite. So the equation of straight line when we plot a line on the graph, then the coordinates, the x coordinate and y coordinate, they have a fixed relation between them. That relation gives the equation of the straight line. So if we plot in the beginning exercise, we have 3, 4, 21.1, 21.2, 3, 4, beginning 4, 5 exercise. They are based on these relations, and we can either the graph is drawn or you have to draw the graph and you have to find that relation. That relation is in terms of x and y, like y is equal to 4, x is equal to 3, or y is equal to twice of x. These are these kind of examples we have in the book also. So we will now shift to the general equation of line. So we have already discussed the general equation of line, the general equation of straight line, that is y is equal to mx plus c, where m is the gradient, and c is called the y-intercept. If we have these are x-axis, y-axis, and any line. So this is a line here with the slope m, and this is a point here. So this distance is called that is y-intercept. So c can be 0, like in this case I have written y is equal to 4x. The value of c can be negative, positive, or if it is passing from the origin, line is passing from the origin, then the value of c is 0. So the next we have the another equation of line that can be represented in this way: ax plus by plus c is equal to 0. Now, so many questions we have. This is also a question of the straight line, and this is also the standard equation. We are saying it as the linear equation in two variables. One is x and one is y, and a, b and c, these are the coefficients. Coefficients of x is a, coefficient of y is b, and c is the constant term. So we can rearrange if you want to go for the slope-intercept form, or that is called this is called the gradient-intercept form. Gradient-intercept form or slope-intercept form. We can change any equation of straight line from this equation to this equation. In this way, we know that dy is equal to minus of ax plus c, and y is equal to minus of a upon b x plus c upon b, where this is called the gradient, and here this is called the this is called the intercept, y-intercept, that is c. Here this is the m. Here m is equal to minus a upon b, which is the gradient, and c is the y-intercept. Our exercise 21.9, that is mostly based on these conversion from one equation. If it is given in one form, you can write in the slope-intercept, or you can say gradient-intercept form. So then we have, or we can take, let me discuss the another topics. Then we take some of the questions from exercise 9.2, and also Puneet has also given some last exercise questions. So we will discuss with you people. So next is the line parallel to the equation of parallel lines. If we have a one line and if you want to draw a parallel line with respect to the given one, as we know, the parallel line, they have the same slope. So let's take the examples. Parallel lines and their equations. So when the two lines are parallel, their slope is always same. Let's take here one example. If we have the two equations, one is 4x minus 2y, 4x minus 2y minus 1 is equal to 0, plus 1 is equal to 0, and another equation, that is 2x minus 4 on y these are the two equations given here, and we have to check whether they are parallel or not. So we can write these two equations in the standard form, that is 2y. First, 2y is equal to 4x plus 1, and y is equal to, that is 2x plus alpha. Here minus 2y, so sides change. Directly I am taking interchanging the left hand side, right hand side. So y is equal to, so both are one and same. 4x minus 2y plus 1, this is of the form ax plus by plus c is equal to 0, and this is gradient intercept form or slope intercept form, whereas this equation we have 2x minus 4 is equal to y, or we have y is equal to 2x minus 4. So here the slope m, that is equal to 2. So we can say that both these equations are of line, or both the lines, they are parallel to each other. Now if we have equation of one line and we have to find the equation of another line, we have one line is given, its equation is given, y is equal to mx plus c, and we have one more point p anywhere, and we want to, here at this point is x1, y1. Now we want to draw a one line parallel, so there will be only and only one line which is parallel to the given line and passing through so in this case, when one equation of one line is given and one point is given, and we want to find the equation of line passing through point P, so we can find the equation of the line, straight line which is passing through point P. So let's take example here. We have one equation of line that is y is equal to minus of 3x plus c, equation of a line in slope-intercept form, and one point is given, that is the P point whose coordinates are given minus 4 and 10. So now the slope of the line is minus 3. Slope here, or the gradient here is gradient of the given line is minus 3. Now we want to find the equation of line which is parallel to this line and passes through these points. As I have explained earlier, one line is drawn and we want to find the equation of another line passing through the given point and parallel to this line. So here we will substitute first the value of x and y in this x and y, which says that y is 10 is equal to minus of 3, x here is minus of 4 plus c. Because we are saying y is equal to mx plus c, m is here minus 3, and in place of y and x we are substituting the value of the x coordinate and y coordinate. So we got here the value of c is equal to, it comes 10 is equal to 12 plus c, and c is equal to 10 minus 12, that is minus of 2 here. So c is the y-intercept. C is the y-intercept. Now we have the slope already, we have the y-intercept, so we can write the equation of line, that is y is equal to minus of 3x minus of 2. So here this is the line which is parallel to this line. These two lines, line 1 and line 2 are always parallel to each other. They are parallel to each other, and this line passes through the point minus 4 and 10 also. So I hope you are clear with this topic. The parallel line, same we have the concept of perpendicular lines. We have if we have two lines which are perpendicular to each other, suppose we have one line here, one line is in this way, and another line is here, they are perpendicular to each other, then we have a relation between their gradients, between their slope. If m1 is the slope of the one line, if m1 is the gradient of the one line and m2 is the gradient of another line, then always the gradient of the one line is the negative reciprocal of the other. It means m1 is always equal to minus of 1 by m2, or interchanging, m2 is equal to minus of 1 by m1. The gradient of the one line, that is the negative reciprocal of the another gradient. From here we have the relation for two perpendicular lines and their equations. We have the relation between their gradients m1, m2 is always equal to -1. So here we have the relation that m1 into m2, the product of their gradient is always equal to -1. So here that is minus of 1. Let's take some example here. We have before example, one more concept is given in this chapter. That is a very small concept and it is related with your coordinate geometry, that the distance between any 2 points. If we have 2 points on the line, that one point is A point and one point is B point, the length of this line segment AB. So we have 2-3 topics and 1 or 2 exercises based on the length of the line segment. Then the midpoint formula, if a line segment is given, how to find its midpoint. So let's discuss if we have a line whose at that line we have 2 points A and B, the coordinates are x1, y1 and x2, y2. Then the distance AB, the length of the line segment. The topic is the length of the line segment. AB, 2 points are given, is always equal to x1 minus x2 whole square plus y1 minus y2 whole square. I have already discussed with you, you can interchange x1 with x2 or y1 with y2. The result will not change, the distance will remain the same here. We are writing x2 minus x1 whole square plus y2 minus y1 whole square. Whether the difference is negative or the difference is positive, square of negative or positive is always positive. So both the ways they are correct. Now if we have the coordinates of the midpoint of the line segment, if you want to find the midpoint of a line segment, like in so many questions, we have the diagram, we have a triangle, quadrilateral, squares or pentagon, hexagon, different polygons, and we need to find their midpoint. So let M is the point whose coordinates are x and y. The coordinates of the midpoint, when M is the midpoint, coordinates are x and y, and M is the midpoint of point A and point P. So here we have the x, the x coordinate, that is equal to x1 plus x2 divided by 2, and y is equal to y1 plus y2 upon 2. So these are the value of x and y, and in so many questions we are using these values of the midpoint, the vertices of the midpoint. So these all are the topics in our chapter 21, and they all are, as you have seen, they are interrelated to each other. So let's take some questions which we have discussed. So here 21.9 is a very long exercise. So many questions are there. And we have total 9 questions. So we can calculate both gradient and intercept. Like question number 7, A part. We have question number 7, A part, that is y plus 1 upon x plus 3y minus 2 upon 2x is equal to minus of 1. So here we have y plus 1 upon x plus 3y minus 2 upon 2x is equal to minus 1. And here in beginning all 7 questions we have to find the gradient of the line and the y-intercept. So we will arrange the equation in the form of slope-intercept form. So here we go for the LCM here. Then we have twice of x. So here it is 2y plus 2, and we have 3y minus of 2 is equal to minus of 1. This implies that we have 5y, 2 and 2 get cancelled, is equal to minus of 2x. So here we can say that y is equal to minus of 2 upon 5x. So here the line is having slope 0. So very simple, you can rearrange. Let's take one more part from question number 8. They are saying here we have to convert the equation into question number 8 here. We need to convert the equation into ax plus by plus c is equal to 0. Like here, let's take the part B part or E part. B part here is y is equal to 2 upon 5 x minus 2. So here again simple one, we have to take LCM here. So we can write y is equal to LCM is 5. Students are committing mistake here. It is very important, you have to go for the BODMAS. You have to go for the LCM. So here it is 2x minus 10. Now we can write 5y is equal to 2x minus 10, or this implies that twice of x minus 5y minus of 10 is equal to 0, or minus of plus 5y plus 10 is equal to 0. Both are one and the same equations. Both are the same equations. That is 2x minus 5y minus 10 is equal to 0, or minus of 2x plus 5y plus 10 is equal to 0. Both are the equations of the same straight line. So next question 9. We have question number 9, one part, interchange. Here, question number 9, you can take like part, like one is there, a part. Here we have the equation of line in this form, that ax minus y upon 2 upon 3x is equal to 1. Write the equation of line in the, again, write the value of a, b, c. So we can again solve the same way as time is less. So we can go for the last exercise, some questions. That is we have on page number 273. Question number 2. Here in question number 2, a diagram is given, and below show a square ABCD. Coordinates of A, B are given, and we have so many points, and we have to calculate the gradient, the equation of line, coordinates of point C, D. So many parts we have. Let me draw. We have coordinates x-axis, y-axis, and coordinates of the square are, square is in this way. And the points, we know the properties of the square. All sides they are equal, and all the four angles they are of 90 degrees. So here A is the point. A is having point 43. B point, that is 10, 5. Let's see, is the point here is having coordinates x1, y1, and D is the coordinate x2, y2. Let's suppose the coordinate of the point C and D are D x2, y2 and C x1, y1. So now first part, the gradient of line AB. The gradient of line AB is equal to y2 minus y1, either 3 minus 5 or 5 minus 3. If you are going with y2 minus y1, like that is 5 minus 3, then we will 10 minus 4. Or if you are writing here with 3 minus 5, then you have to write here 4 minus 10. Both the way gradient will remain the same. So here we have, that is 2 upon 6, that is 1 by 3. So the gradient of this line, the line passing through the points AB, the gradient is 1 by 3. So the first part, gradient is 1 by 3. Second, we have the equation of line passing through A and B. Now we know we have the gradient. We know the equation of line. Second part, we want to find the equation of line which is passing through point A and B. So here we will apply in the same way as I have discussed with you. Gradient M is given, M of the line that is 1/3. The coordinates of A are 4 and 3, and B, they are 10 and 5. Right? Equation of line is y is equal to mx plus c. The equation of line, that is y is equal to mx plus c. So here slope is given, that is y is equal to 1/3 x plus c from any point, either point A or point B. You can substitute the value of coordinates. So here either A point or B point, substitute the value of. If I am substituting the value of A point, so here this is 4 and y is here 3. So here I will get the value of C. I have chosen here the first point and I am substituting the value of x and y. So here I have, let me solve, or here let me solve this one, that is 4/3 plus c is equal to 3 here, and c is equal to 3 minus 4/3, which is equal to 9 minus 4, that is 9 minus 4 upon 3, which is equal to 5 upon 3. So the value of c here, m, already we have found, that is 1/3, c is equal to 5/3. So we have the equation of line. That second part, that the equation of line which is passing through these 2 points, that is y is equal to 1/3x plus 5/3. Or in another way, we can write 3y is equal to x plus 5. Just taking LCM and cross multiplying 3 that side. So this is the second part. One more thing, here we can get this value by substituting. The value of c will remain same if I am going to point B. Suppose here in place of x and y, if I am substituting the value of B as, that is 5, here is x, this is y, x is 10 here, and y is 5. The value of c, or we can say the y-intercept, that remains the same, because we are talking about one line, that is the line passing through the points A and B. So here let's calculate. If I am calculating, y is equal to 10/3 plus c, or we have c is equal to 5 minus 10 upon 3. So c is equal to, LCM is 3, 15 minus 10, that is equal to 5/3. So in any case, so I hope you are very much clear with this point. So in the same way, I don't think there is any problem now to solve these questions, but still, if you have any doubts, if we want to find the coordinates of these points, midpoint, any midpoint, line perpendicular, in the same way, we know the relation of the parallel lines and the perpendicular lines. In place of the slope, we can put the value that for the perpendicular lines, the slope of, let is the slope 1 by 3, the slope of AB is 1 by 3, the slope of this line, that is always equal to minus 1 by the slope of M2. So here in this case M1 is equal to minus of, that is 1 by 3, which is equal to minus of 3. So for these two lines, the slope, that is line BC and line AD, slope is minus 3, and it is confirmed. We know M1 into M2, that M1 into M2 is always equal to minus 1. So this is a very simple topic, easy topic, the straight line graph, but think everything that is interrelated. So I hope, dear Puneet, you got the question how to solve. The another third question is also same, triangle is there. We can find all the vertices in the same way, the same manner, right? So time is over. Thank you very much. Stay safe, stay healthy. God bless you.